Hey everyone, I am sorry that I am out right now. I am currently attending a wedding in California. However, as of filming this is actually spring break, but I wanted to get a chance to go over everything that you're gonna be doing in your practice book over the next week while I'm gone. And so that's why I'm filming this. If you have any questions, feel free to email me and I'll try to see it when I can. Also, feel free to go to Miss Blackington or Miss Knight if you have any questions. But right now we're going to start with section 6, topic 3. So go ahead and turn to page 94 in your practice book. I'll give you a second, but you can also pause it. All right, so our first question in this section is a model rocket was launched from a podium 5 meters above the ground at an initial velocity of 98 m per second, which is meters per second. The function that models height in meters with respect to time in seconds is h of t is equal to 5 plus 98t minus 4.9t squared. So for this first one, we're going to need a calculator. So go ahead and grab a calculator. Pause me again. Grab a calculator. And we're going to be plugging these numbers into the formula. All right. So first, we're going to plug in 0 for t. And so 0 squared is 0, 0 times 4.9 is 0, 0 times 98 is 0, and then plus 5 is all we're left with. So we get 5. And then we're going to plug in 5. So on your calculators, go ahead and do 5 squared. There should be a button to square it, or you can do 5 times 5, and then times negative 4.9. Once you have that, you're going to do 98 times 5 and then subtract that from the current number or add it to the negative number. And then add it by 5. You should get about 372.5 feet. All right, and now we're going to plug in 10. 10's a little easier. 10 squared is 100 times 4.9. Well, negative 4.9, so that gives you negative 490. 98 times 10, that gives you 980. And then subtract those two and add them by 5. And you get 495. 495. All right, now with 15, you should get 372.5, and then with 20, you should get 5. So, as you can see, this is a quadratic equation or a parabola. It starts down by 5, goes up, and then goes back down by 5. So, if we were to draw this on a graph, you can go ahead and label your sides in 50s. And that'll be, and then you can go by 5s, but skip 1, and those will be your 2.5s. So we have elevation on the side and time in seconds. Elevation is per meters. I didn't label that. I should have, but I mostly labeled time in seconds because that's going to be coming back up in just a moment. So we'll go ahead and plug those in. So at 0, it was 5. And then 5, it was 300 something, 10, 15, and 20. So it's going to look something like this. Feel free to pause it if you need an extra minute. But I'm going to move on to the next slide. All right, estimate the time when the model rocket lands on the ground. All right, so we already did the graph. It It looks like this, and I accidentally did not animate that. I might edit this slide, but just in case, because I feel like we have a good rhythm going. Does this make sense? The rocket will hit the ground right after 20 seconds. Here, I can circle it. The rocket will hit the ground right after 20 seconds, because right here is 20 seconds, and it hits the ground right after 20 seconds. Not at 20 seconds, because remember, when we plug that in, it's 5 meters at 20 seconds, but basically right after it hits the ground. You could try to get more exact, but it's not worth it. All right. So now let's look at these. Consider the following tables of values, and which of the following is the graph that represents the table of values. So we want at 0, we want it to be at 3, which is not the case. You can see right there, 3. -1, we want it to be 8, not the case. At 2, we want it to be -1, not the case, not the case, not the case. See where I got those numbers? Again, when x is 0, it should be 3. When x is -1, it should be 8. When x is 2, it should be -1. Here, though, look at this. 0 should be 3. Yep. At -1, it should be 8. Yep. At 2, it should be -1. Oh, yeah. At 4, it should be 3. Yippee, yep, yep. And at 5, it should be 8. Looking good. Looking great. I think we know which one it is, but let's be sure. Let's do the same thing on this one. Yeah, no, these aren't even close. This B is going to be our perfect answer right here. So you can go ahead and circle B in your books. Perfect. All right, so for this one, we're going to graph a certain geographical location, and we're looking at the average rainfall over the month. So you can either label your sides to be mostly in the 70s and 80s, because as you look the inches, it's between the 70s and 80s. Or you can go by 5s, is what I chose to do because it looks slightly more accurate. And then the bottom, you can either label it by months or label it 1 through 12. Then you're just going to plot your points. So for January, 72, February, a little over 75, March, a little over 78, or kind of between 75 and 80 if you labeled it the way I did. 81, 82.6, 83.6, 84, that's going to be our peak. And then we're going to slowly work our way back down through the months. Feel free to pause and take a minute to graph your quadratic equation, or your points, I mean. But you can see that it's a quadratic equation. It's a very small one, but it's slowly going up and then working its way back down. So the next question we're going to look at has to do with the amount of rainfall. So think about this, looking at this graph before I switch to the next one. It's a lot of rain, at least 70 inches. That's quite a few, you know, that's over 6 feet. So this one asks what geographical location is represented by the graph. So think about it. You're getting a lot of rain every month, and that's a lot of rain. So it's probably a rainforest, would be my guess. And you can put any rainforest. I just left it vague because it doesn't give us an exact detail. All right, so now we're looking at this quadratic equation. F of x is equal to -x² plus 8x. And then this is his work right here for Pierre. Not sure if you can see my mouse, so I'll do it like this. All right, so now we're going to complete the table below. So let's plug in certain numbers. So 0, easy. 0 squared, 0. 8 times 0, 0. Now let's plug in 1. And you can use your calculator, but 1 squared is 1, and the negative is on the outside. Keep that in mind because that's going to be -1 plus 8. So 8 plus -1 is the same as 8 minus 1. You get 7. Then plug in 2. 2 squared you should be able to do in your head. That's 4. The negative's on the outside, so -4. 8 squared, you get 16. So going to be the same as 16 minus 4. You get 12. All right, so now we're going to keep working our way down. You have, you're going to plug in 3. 3 squared, you get 9. 8 times 3, you get 24. 24 minus 9, you get 15. And then plug in 4. And then 4 squared, 16. 8 times 4, 32. If you're on a number like this and you're struggling with thinking of what 8 times 3 is or 8 times 4, keep in mind you're slowly going up. So you did 8 times 0, which is 0, and then 8 times 1. 8 times 2 is going to be whatever you got here, which is 8, plus 8, and then plus 8 here. So 16 plus 8, you get 24. 24 plus 8, you get 32. And then on the next slide, we're going to fill in the rest. All right. So now we're going to plug in for 5. So 5 squared, you get 25. Negatives on the outside, and then 8 times 5, you get 40. Because remember, the last thing you got was 32. We're going to go 8 more, which is 40. You also hopefully know that 8 times 5 is 40. And then again, you're going to go 8 more on the next one, but we're going to do 6 squared. 6 squared is 32, -32, 36, I'm so sorry. And then plus 48. And then of course you're going to do 48 minus 36 or -36 plus 48. Either way, you're going to get 12. And then we're going to do the same thing for 7. And then we're going to do the same thing with 8. All right, so you can kind of see, and you might not have even had to do, I mean, I would love to see your work, but you might not have had to even plug in the way you did for the last couple, because once you notice the pattern, because if you look right here, 0, 7, 12, 15, 16, 16 is our highest, now we're going back down, 15, 12, 15, 12, 7, 0. Does that make sense? I hope so. All right. So, whoever Pierre's teacher was realized he's not right. He's incorrect. He did something weird and wonky. So let's look at that for a second. So, if we plot these points, let's start out with 0, 0, very easy, and he got that right, but right after that, 1, 7 would be over here, 2, 12, 3, 15, 4, 16, 5, 15, 6, 12, 7, 7, and 8, 0. Interesting, right? Okay, so as a teacher, I want to see what he's confused about. So why did he put what he put? Well, if we look, let's look at the vertex. So our vertex is at 4, 16. This vertex over here at -16 on the x, and then 4 on the y. So he mostly mixed up his x's and his y's, which is how he ended up with this shape. However, he also made his new x's negative, or what would be the y's. So Pierre was mostly on the right track, he just mixed up his coordinates. So this is kind of my explanation right here. Feel free to copy that down. And that concludes section 3. So please message me if you have any questions. Feel free to visit one of the surrounding teachers, Miss Knight, Miss Blackington, Mr. Miranda. All would be happy to help answer any questions about these. Hopefully this section made a lot of sense. It's mostly a lot of plugging stuff in, but yeah. All right, see you in the next section. Hey everyone, we're gonna do topic 4. Foz is here to help, right, Fozzie? Fozzie says yes. He's very excited for topic 4. All right, so let's go ahead and dive in.